Alrighty, so for worksheet 17, most of it is stuff you've already done, so it's just continuing practice. But there is some exception here. An exception is that you need just a little more practice with these guys. Let's put it this way. If you felt the last time we did this, which was a couple worksheets ago, I think worksheet 15, if you thought it was no sweat, super easy, then you probably don't need to watch this video. But if you thought that was just a little bit weird and you need a little more practice, that's what this is for. Okay. So what if we want to find the derivative of f of g of x at x equals, let's do 1. Now, I don't want you to feel like these labels are permanently attached like this. Okay, so because we're doing f of g of x, f is, I would think of this axis as being f, and think of this axis as being g, and think of this axis as being g, and this axis as being x. Even though we use x to mean that's your independent variable. So it's totally fine to relabel your first x-axis as g, at least in your mind's eye, so that you remember how these things nest together. Otherwise, you might be tempted to stop the process too early. Okay, so we need to know what g of 1 equals, and in this case, let's figure out what that is. So g of 2 would be 3, g of 0 is 2, g of 1 is 2.5. Okay? So we want to evaluate f at 2.5. So you want to evaluate f right here. F at 2.5 is going to be, so that guy goes in there. F of 2.5 is negative 1. So that's the derivative we need. But we need the derivative there, which is negative f prime at 2.5 all by itself would just be a negative 1/2. But you multiply that by the derivative of g where it came from. So g prime at 1 is going to be 1/2. So you multiply these guys together and get minus 1/4. Okay, what about at x equals 2? So let's try that. So g of 2 is equal to 3, and f of g of 2, or f of 3, this part we don't really need, but I'm just trying to get my bearings here. F of 3 is negative 2. We don't need that, but we need the derivative there. And the derivative there is negative 1/2. And we need the derivative where we started, g prime at 2, and that derivative is 1/2. So that's negative 1/4. Okay? We shouldn't be that shocked because we were working with the same two pieces of function. So let's try what happens if we do 0. I mean, we really don't get out of the gate at all because g of 0 is 2. Let's see, let's just go ahead and try that. G of 0 is equal to 2, but we know that down the road we're going to need g prime of 0, and that does not exist, so there's no point doing that. And similarly, there's no point in calculating it at negative 2. F of g of negative 2 is also 0, but the derivative here doesn't exist. So even though the function is continuous, it is not differentiable at these points that I'm circling. Okay, those are not, they're not discontinuous, but they're also not differentiable. They are continuous, but they're non-differentiable at those points. Okay, so the other thing we can do, which this worksheet encourages you to do, is to split this up into regions, to say, hold on a second, if it's f of g of x, this whole piece only goes over to this function. In fact, both of these pieces end up coming over here, and then this piece over here, let's see, the first little line segment in G winds you up at in the negative half, so you're going to end up over on that side. So let's just map this out. Let's see, we should have at least 3 different regions and see what happens. So we have a region where x, so f of g of x for x is positive. So x is greater than 0, then g of x is equal to what? Well, we know what this function is. This part right here is going to be y equals 2 plus x over 2, right? So g is 2 plus x over 2, and because we can only get values between 3 and 4, we're going to be on this piece of curve when we shove that into f, and that is 4 minus x over 2. Okay, so f of g is 2 plus g over 2, because I just don't want to use the letter x again. But what is g? Well, so f of x is 2 plus x over 2. Not this f of x, f of this x, because we've already composed it. Okay? So in that case, let's untangle this. 2 plus 1 plus x over 4, which is equal to 3 plus x over 4. So if we're going to have a grand unification theory for these guys, I just made that up. It's very silly. Okay, so it's 3 plus x over 4 when x is less than 0. Okay? Now, there should be another range in here when x is between negative 2 to 0. Right? So what if x is between negative 2 and 0? Okay, great. So what is this function over here? This is 2 plus x. Pretty simple. And so if g of x, so f of g is what? I don't know, but g, I know what g is. G is 2 plus x. And which f do I have over here? Is that the one I'm going to use? No, because it's going to land me between 0 and 2. So I'm going to still be on this original one over here. So f is going to be, f of g is going to be 4 minus g over 2, but we know what g is, so f of x is 4 minus 2 plus x all over 2. So this function is going to be 4 minus 1 minus x over 2, so it's going to be 3 minus x over 2. So 3 minus x over 2 for x between 0 and 2. I'm not worrying about the inequalities. That's just not something I'm worried about right now. We could worry about that later, see if it's continuous and all that jazz, but I'm just worried about everything else right now. What if x is less than 2? Well, then g is going to be down here. And that function, let's see, if I were to continue this up to here, continue this function, it would go up to 4. So this is y is equal to 4 plus x over 2 is what it looks like to me. And so that is g. I called it y. I'm going to call it g now. But now I have to contend with this piece of f. Okay? And so that is going to be 4 plus x. So f of g is 4 plus g, but we know what g is, so f of x is 4 plus 4 plus 8 over 2. So this is going to be 8 plus x over 2 for x is less than 2. So we've now analyzed the different regions, and now we can dispense of all this nonsense, and we can just look up on our chart. So that was a lot of pain and suffering, but you have two options. Since you've got the Blackboard quizzes, you can either just do hunt and peck. You can basically do trial of error, or you could exhaustively trace out all the possibilities and figure it out that way. So you have two options. And I don't actually care which way you do it, as long as you get a little practice with this and feel a little more comfortable. I just wanted to give you like another technique for doing this. Okay? Everything else on the worksheet is stuff you've done before. I will give you a little bit of a hint though. You have, with the following type of question, if you want to find the derivative, you have of cosine of arc sine of something, and it's x plus 1, but it could be anything, okay? You could either go ahead and use the chain rule just outright with what you know, or you could simplify this first. And it's about an even bet which one's easier, but the point is, if you try it one way and you find that it's difficult, you're welcome to back out and try a different way. I want to show you how to simplify this algebraically. So you have a theta here, and, well, I'm sorry, I don't want to put a theta here. I want to put a t here. Sorry about that. This whole mess right here is your theta. So that's your theta. And your theta is an angle whose sine is t. So how do you make a sine of t? Well, sine is y over r, so that triangle has a sine of t, which means if you reverse engineer what has to be on this side, okay, so you have a squared plus b squared equals c squared, and you have to figure out what's on the other leg. So what is the cosine of theta? Well, it must be t squared, square root of t squared minus 1. So for example, you could choose to do the algebraic simplification first and then take the derivative, or you can take the derivative and then do one of these simplifications, because if you just plow through this derivative, you're going to still end up with this kind of messiness when you're done. Not exactly this, but something very similar, and you're still going to have to untangle it in order to get everything to work out. Okay? So that's a little hint. You can go either way on that, but once you finish, no, either way, it's a pay me now or pay me later situation. It's not particularly easier one way or the other, but just know you have two different paths through that forest. And questions at the end of the worksheet. If you're struggling with that, you probably want to watch the end of worksheet 16, honestly, because it's those concepts that we're reviewing. And it's just in a little of different guise, but it's this idea that you have two functions. One is the inverse function of the other, and you have something going on each side, and they're reciprocals, okay? And so that's the whole of that discussion. Okay, so hopefully that's enough hints to get you through the worksheet, and I'll see you in class.